Okay, so now let's do some investigation of the cotangent. Right? So what's this graph going to look like? What's the analysis going to be? So we know in this case the cotangent is defined to be cosine over sine. And so now the problem is that we have a division by zero or vertical asymptotes when sine is equal to 0. And of course we know that happens at 0 and at pi. So right away, without sketching any other data points, we know, right, that at pi there's a full rotation, but at 0 we have a vertical asymptote, and at pi we have a vertical asymptote. As a matter of fact, at 2 pi we're going to have a vertical asymptote, and we can even go back in time. If we were at negative pi, we have a vertical asymptote, because at all those 180 degree or 0 rotations or coterminal angles, we know that sine is equal to 0. Okay, and then looking at some other special values, again, let's use the big ones. We can talk about, here's pi over 2, so we can talk about negative pi over 4, right, and negative 3 pi over 4. And then same thing here, right? Here's pi over 2, pi over 4, and 3 pi over 4, and on and on and on, right? So here's 3 pi over 2, and this would be 5 pi over 4, and this would be 7 pi over 4. So those are some nice values. So let's take a look at those. So when we are basically trying to find, let's just say, the cotangent of pi over 4, right? Well, again, in a rotation, that's a 45-degree reference, and we know sine and cosine are equal to each other, so we get 1. So pi over 4 is going to give us a 1, right? The cotangent of 3 pi over 4, well, in this case, we're down here with a 45-degree reference, and the x is positive and the y is negative, so we're back to negative 1. So that's negative 1 down here. And then the cotangent of pi over 2, well, sine is 1 and cosine is 0, so this is 0. And so we can already begin to see that this graph, using the fact that we have asymptotes there, is basically going to do that behavior from 0 to pi. So there's a vertical asymptotic behavior at 0, there's vertical asymptotic behavior at pi, and then we just filled in some details with regard to that. And what's going to happen because of the coterminality is this is just going to continue to repeat itself forever and ever and ever. All right, so it'll be the same action pretty much over those whole things. So there's basically your graph, and how about we just focus on that. Between 0 and pi, that is your basic cotangent shape that's just going to keep repeating every half rotation, every half rotation, every half rotation. So with that in mind, what can we say about this? Right? What are some analysis we can do with this? Well, first of all, so we can get ready to do the point plotting that occurs. The major points are this: at 0 we have an asymptote. At pi over 4 we're equal to 1. At pi over 2 we're equal to 0. At 3 pi over 4 we're equal to negative 1. And at pi we're equal to 0. We have an asymptote. Okay, so when we do some analysis where we start transforming these graphs, as you saw with sine and cosine, we just basically manipulate some core data points. If I can find out what those core data points are, I basically have at least one period of my new graph. What else do we see about this? Well, number one, we see that the domain, right, is all x not equal to, right, and it basically looks like we have multiples of pi, right, where n is equal to an integer. So at pi and 2 pi and 3 pi and 4 pi and negative 2 pi, right, that's consistently where sine is equal to 0, so we have vertical asymptotes. The range, well, we've seen this before, but now we can visually see it, right? The range, we're going to positive infinity to negative infinity. So the range is everything. There are no extrema because the graph is constantly depending on things going up or going down. So we never reach a high point, we never reach a low point, right? So we got that action going on, right? And it's kind of hard to see, and I'll point it out to you, but this is actually an odd function. right? Which means that if we took the cotangent of negative x, that would be the same thing as the cotangent, negative cotangent of x. And probably again, if we just did a double flip, right? So we flip this down and flip this over, we're right here, right? If we flip this up and flip it over, we're right there. So it is symmetric. Or if you just thought about taking this graph and rotating it around the origin at 180 degrees, which is technically what's going on, we are symmetric, right, about the origin. So this makes it an odd function. So we got that, no extrema, we got domain, we got range, we have the fact that it's an odd function, all that other really good stuff. Okay, so there's our graph of cotangent. Its basic shape, oh, by the way, too, its period, right, is also pi, right? So it just takes a half rotation from 0 to pi to basically generate everything this graph is going to do, right? And then if we go another pi units, we've generated the graph again. If we want another pi units, we generated a graph again. So that's a classic period. So that is, again, something a little different than sine and cosine. So putting these together, they're very similar, right? Here's your graph of tangent, right? It basically has asymptotes at negative 90 and 90 degrees, or negative pi over 2 and pi over 2. And it's essentially increasing, right, all the way through, going through 0, 0, negative pi over 4, 1, pi over 4, 1, asymptotic behavior. Cotangent, right, is a little different. It's actually decreasing the whole time. Its asymptotes are at 0 and pi, and then pi over 4 is positive 1, and 3 pi over 4 is negative 1, and we basically have that. So they're slightly different, and I think one of the big cases is this repetitive asymptotic behavior, but as we move left to right, tangent is always on the way up and cotangent is always on the way down. So maybe that's one way you can distinguish them. Of course, right, we can always flip things around and make tangents to cotangents by doing some transformations. But that's what we're going to do here shortly in a moment. But there's your basic shapes, and let's get to those crazy transformations. See you in some videos soon.